During the data preparation stage for analysis, for example, when using decision tree techniques to estimate the occurrence of a phenomenon, ensuring the proper representation of the studied feature is essential. Let's consider the issue with an example. The unemployment dataset contains information about beneficiaries of employment offices who participated in training sessions over the past year. The key information is the answer to the question, whether they managed to find a job within 3 months after the training. Let's create a simple summary. By right-clicking on the top bar and selecting descriptive statistics for the variable job acceptance, we see that only 20% of people found employment. Using this data for further analysis, considering job acceptance as the predicted variable will distort the results because the response yes will not have the same chance as the response no, which appears in nearly 80% of observations in the dataset. Thanks to the functionalities available in PS IMAGO Pro, the user will have the ability to mitigate this effect and quickly prepare the data for analysis. In this example, it is sufficient to use the distribution balancing procedure. It allows preparing a dataset for modeling in which the predicted variable values will have an equal probability of occurrence. Go to the Predictive Solutions menu, then Data, and select Balance Distribution. In this simple window, you only need to specify the variable whose distribution will be balanced. In our case, we indicate the variable job acceptance and additionally pick the Yes option below, which will cause part of the data to be filtered out. Click OK. As a result of the procedure, we see the filtered out excess observations containing the response no. Filtering is based on a newly created variable, job acceptance balance, which contains values of 0 for rejected observations and 1 for those to be included in the analysis. To confirm the correctness of the procedure, let's create the statistical description again. We can see that now both responses have the same distribution and thus the same probability of occurrence in the new model. What is also noticeable is the unchanged count of the less frequent category. This procedure will always filter out more numerous categories, and, for example, in a situation where the variable has 3 values, the count is adjusted to the least numerous. This makes it easy to balance the dataset and ensure that the predictive model considers each category equally.